Ma'am,
Yes, Bedullah.
should that be 40 square plus 40 square?
40 plus 40. Where?
And last part,
Oh, yes, this is 40, not 22 is written by mistake. Yes, this is 30 square plus 40 square. That forms a Pythagorean triplet, no? So 50 would be the answer. Okay. Ali, this exam is when? 18th, Sunday. No, 18th is on Thursday. Okay, so 45 minutes. Combination of capacitors, difference between me. What is this, Ali? The topic that you have given separately? Me, okay, the miscellaneous concepts from the previous chapters. Okay. Okay, so these will be coming, EMI and AC. Okay, let's see. I hope you don't have trouble with any of the things that have been taught before. Okay, then let's see how much we are able to complete this chapter. See, here this topic is actually, this question is from resonance part. Let me discuss what exactly is resonance. Resonance is a condition. See, if your value of inductive reactance and the capacitative reactances are equal, okay? If we say XL is equal to XC, so what will happen? XL minus XC is equal to 0. Okay, values of XL and this XC, this is equal to 0. So what will happen? The value of Z will be equal to under root R square, where Z is equal to R. Okay, this is under root Z is equal to under root R square, where Z is equal to R. So see, here you were getting a bigger value of the impedance, because whatever is it was after, even after getting subtracted, it was greater than the individual values of resistance. This value and the summed up value together was greater. So here, like, I'll give you the example which we did. Look, resistance is just 40 ohm, while the combined resistance, even after subtracting and all, the impedance is 50 ohm. So what has happened? When it is just equal to the resistance, the value has decreased. The value of impedance now has decreased. And what is current? Current is equal to voltage by impedance. So if impedance is very less, current will be very high, current will be more. So impedance is less, current will be greater. So basically resonance is a condition when the current in the circuit is maximum, when the current reaches a very maximum value in the circuit. So a series LCR circuit is said to be in resonance when current through it has a maximum value. So impedance in this case will be minimum. Okay, this is what is meant by resonance. So in this case, what happens? XL and XC's value are the same. Means when I say XL and XC, they are the same. Inductive reactance is equal to the capacitative reactance. Now, inductive reactance is what? Omega L. Capacitive reactance is 1 by omega C. So if I interchange this, omega into omega is equal to 1 by LC. So omega square is equal to 1 by LC. So from here I can say omega is equal to 1 by under root LC. Okay, so this is the derivation for angular frequency. Now see, if I say the for the linear frequency, because the derivation comes from the linear frequency, angular hardly comes. Omega is equal to 2 pi into the linear frequency. So linear frequency will be the angular frequency divided by 2 pi. So angular frequency will be 1 by 2 pi into 1 by under root LC. So this is the whole formula. I'll tell you this one. See, this is the angular frequency, while this is the linear frequency. This is the linear frequency. So angular frequency and the linear frequency. Basically, you have to remember that XL's value is equal to XC. And in this case, Z is equal to R. This part also you need to remember. And along this, you have to remember that the current in the circuit will be maximum. I will have a maximum value. These three things will constitute your resonance. And this derivation of the frequency often comes in the exam to write. So am I clear till here to all? Hmm?
Yes, ma'am.
Okay, from this resonance condition, please start writing.
Ma'am, can you scroll? Done.
Done?
Yes, ma'am.
Okay. See, let's see this question. This is a resistor of 12 ohm and a capacitor of reactance 14 ohm and a pure inductor of inductance 0.1. See, inductive reactance is not given to you. Only the value of inductance is given. Okay. What all things are given? Resistance is given as 12 ohm. Capacitive reactance is given as 14 ohm. Inductance is given, not inductive reactance. Okay, class, because 0.1 Henry is placed. They all are joined in series and placed across 200 volt 50 hertz supply. See, I told you whatever is the supply, that is your RMS value actually. RMS is given as 220 volt and frequency is given as 50 hertz. It is current in the circuit. To find out the current in the circuit class, current is basically Current means IRMS will be VRMS divided by Z, the impedance. So we'll have to calculate the value of impedance first. So for Z, I need R, I need XC, I need XL. How to calculate XL using this data? Yes. No, 2 pi frequency into L. Very good, Ali. Correct. See, XL is equal to omega L. Omega is not given, so we are going to move to 2 pi nu L. XL is equal to 2. Pi is, it says take pi as 3. Frequency is 50. Inductance is 0.1. So this will be 30. XL will be 30 ohm. This is 0.1. Now, XL is there, XC is there, R is there. So we'll get Z is equal to under root. Now from here, XL is greater. So formula will be XL minus XC whole square plus R square. XL minus XC, 30 minus 14. Z will be, this will be 30 minus 14 whole square plus resistance is 12. So this will be 12 square. Okay, so Z will be, this is 16 whole square plus 12 whole square under root. So 16, 12, this makes a Pythagorean triplet, no? 15. Z should be equal to 15 or 150. Do they make this? 16 and so 256 for 16 and 144. No, 20. 400, not 15, 20. This is root 400. So that will make Z as 20 ohm. Okay. Now calculation of IRMS. VRMS is 220 divided by 20. 2 will get cancelled here. So IRMS is equal to 11 ampere. This is equal to 11 ampere current. Second phase, calculate the phase angle between the current and the voltage. So for this, you can use any value for calculation of it. You can use cos phi, you can use tan phi. You are free to choose any value here. Okay, cos phi you choose, tan phi you choose. It's better you choose tan phi only. Anyways, you can calculate any values. Okay, so tan phi will be, see it will be XL minus XC divided by R. This is 16 divided by 12. So we can say this is 4 by 3. So phi is equal to tan inverse 4 by 3. Clear?
Ma'am, I think that volt is 220.
200. Oh, yes, this is 200. Correct. Not 220. This is 200, then here also we'll get 200. So this will be 200. So that makes it 10 ampere. Anywhere else? No. Okay. Now fine.
Yes, ma'am.
Please write down this question. Then we'll discuss the topic Q factor, quality factor from this. Please write it.
Ma'am, why is it saying pure inductor?
It is and pure inductor of inductance means we take a pure capacitor, pure inductor, and a pure resistor, and then combine them in LCR circuit. Combine them in series. The pure inductor is there. Okay.
Yes, ma'am. So it means it is not LCR.
This is LCR. Inductor in LCR circuit, you take a pure inductor, you take a pure resistor, and you take a pure capacitor and connect all of these in series. That's why this is known as series LCR circuit. Okay. So these are individually, these are purely resistive, purely inductive. No, they didn't have any other circuit within them. That's why pure inductor is mentioned. Fine.
Yes, yes. Ma'am, how should we know that it should be RMS?
Supply.
This
See,
RMS.
yeah. See the supplying one, that is the RMS one, no? The voltage which is supplying the circuit. Then see, values are different. And then out of all those values, you get a very maximum value, which is known as the peak value. So the supplying one is the RMS. Okay.
Yes, ma'am.
Done.
Done.
See, now the term is quality factor. Q factor basically means quality factor. Now, quality factor, see, quality factor basically the sharpness of resonance. Different values will be there for XC for XL. Though those values will be the same to each other, but those values can differ. So Q factor basically means quality. It tells you the quality of the resonance. What's the quality? How sharp is your resonant, or how blunt is the resonance condition? So Q factor basically tells about the sharpness of the resonance. Now, see, when we talk about the Q factor, it tells about the sharpness of resonance. So you can understand it like this. Let's say this is a middle point here. Current versus angular frequency graph I've drawn. So here, this is the lowest peak value for resistance. Means here we will have, if the current value is lesser, from the graph we can see the current value will be less from here. So you will get a very high value of resistance. There will be high resistance. If I plot a graph like this, that gives a moderate value because current is also moderate. So that gives a moderate resistance. And if we get a peak curve like this shows a high value of resistance. Okay. Sorry, not high, this will be a low value. This will be low value for resistance. Now, why? Because current is maximum. So current and resistance, they are inversely proportional to each other. That's why this sort of graph. So how sharp is your resonance is given by this term quality factor. Now see, let us understand the definition of this quality factor. See, like this, if I read, it will be difficult for you to understand. Let me tell you it through a graph. So using this, you will be able to understand its definition better and you will be able to remember it. But if there's any trouble, please stop. See, current versus angular frequency. Here, point I'll choose which will represent the resonance frequency. Resonance frequency 1 by under root LC. This is the resonance frequency. Okay. So when we plot the graph here, let's say we get sort of bell-shaped curve from here. Now what I do, I mark out 2 points from here. Means one value from this side of the curve, another value from this side. Means the resonance frequency is there, then the values of frequencies on either side of the curve. Means this will be, let's say, omega 1. This is the value omega 2, two values. And this maximum that you can see from here is maximum 1. This is actually 1 by root 2 times the value of the current at resonance. The maximum value of current is 1 by root 2 times the value of current at resonance. Now let's understand what exactly is the meaning of the bandwidth of the quality factor. See, quality factor is basically the ratio of two things. First, the ratio of this resonant frequency, that is omega r. To what? Omega r means the resonant frequency. To the difference between these two means omega 2 minus omega 1. What are omega 1 and 2? These are the just immediate values near your resonant frequency. A little before it, a little afterwards. So Q is omega r by omega 2 minus omega. Now remember this omega 2 minus omega 1. This is also called as the bandwidth. This is called as the bandwidth. We often use this term bandwidth is very high. So voltage supply is very high or the internet is working very well or bandwidth is low. So like this, we use the term bandwidth. Basically, is the difference between the angular frequencies of both of them. So omega 2 minus omega 1, this is the band. So we can say quality factor is what? It's the ratio of resonant frequency. The quality factor, it's the ratio of resonant frequency to the bandwidth. Okay, it's the ratio of the resonant frequency to the band. Now, what is bandwidth? Bandwidth is basically the difference between both of these, omega 2 minus omega. Okay. Now let's read the definition. Now you'll be able to remember it also and understand. See, this says quality factor, Q factor or quality factor of a series resonant circuit. Series resonant circuit means series LCR circuit at the resonant condition when XL is equal to XC is defined as the ratio. Now, ratio of what? Ratio of resonant frequency, that's your first thing, to the difference, means you are subtracting two things, one and two, you're subtracting them. Difference in what? Two frequencies taken on both the sides of resonant frequency. These two frequencies taken on resonant frequency, their difference, such that at each frequency, the current amplitude becomes 1 by root 2 times the value at resonant frequency. This one which I was saying, the maximum value will be 1 by root 2 times the current at the resonant frequency. So Q factor or quality factor of a series resonant circuit is defined as the ratio of resonant frequency to the difference in two frequencies taken on both sides of the resonant frequency, such that at each frequency, the current amplitude becomes 1 by root 2 times the value at the resonant frequency. Now, is this big definition clear and understandable for all of you?
This 1 by root 2, I'm not able to understand.
Means whatever is the value of current at resonance, whatever is it, 5 ampere, 6 ampere. Quality in quality factors graph, that maximum value will be 1 by root 2 times that. In the denominator, it's like your impedance is becoming root 2 times. The impedance is becoming root 2 times. Remember it like this, it is easier to remember. Impedance becomes root 2 times the resistance. Impedance is equal to resistance. At resonant, we did Z is equal to R. So Z will be equal to root 2R. Okay?
Yes, ma'am.
Z will be equal to root 2R, because see, in the denominator you get Z and this is root. So for current will become 1 by root 2 times. Okay. Now is it clear to everyone? Okay, except Ali and Ubaidullah. What about others? Anisa, Aisha, Marwa. Getting it? Yes, others.
Yes,
Anisa, what about you? Are you understanding anything, Anisa?
Yes, ma'am.
Write it down, class. Then this question you have written. Then we'll do a derivation of this Q factor. Please write it.
Ma'am, can you scroll up? Done.
Just tell me done once completed. Okay, so see, the value of impedance is equal to root 2 R. Now see, at resonance, the impedance value is equal to the resistance value. So this time in quality factor, the impedance value is root 2 times the resistance. So when I write equation of resistance, that is R square plus, now XL minus XC or XC minus XL, whatever we choose, let's say XL minus XC. So XL is omega L minus 1 by omega C is equal to root 2 times the resistance. Now let's square both the sides. So R square plus omega L minus 1 by omega C whole square is equal to 2R square. If I square both the terms, LHS and RHS. Now see, if this R square goes on the opposite side, we'll get omega L minus 1 by omega C whole square we get is equal to, see, 2R square minus R square, that gives R square. Now see, when we take the roots, I hope you know whenever you take the roots, let's say 4 is there, when you take the roots, it will be plus 2 minus 2. Actually, the roots, when we take the roots, 1 is positive, 1 is negative. So here also the root values will come out to be 1 positive R, 1 negative R. So since we have two frequencies on either side of the graphs, we take one as 2, another one as 1. So omega 2L minus omega 2L is equal to plus R. Omega 1L minus omega 1C is equal to minus R. So this is one equation. This is second equation. Now we add both the equations, first and second. See, this is the first one, omega 1L minus 1 by omega C plus this term omega 2L minus 1 by omega 2C. This is C. Okay, is equal to plus R. So plus R minus R is there. Now, first, before we go on to this addition, tell me till here, have you understood? We have got these two equations. Why two? Because of the root values. And one we have taken it as 2, other we have taken it as 1. Now clear? Is it clear till here? Okay. See, when we add them,
Ma'am,
yeah.
how these two equations came?
See, when you take the root values, no, whenever you have the root values. So for root values, you have one as positive, other as negative. Like when we usually ignore the negative one for most of our calculations. Negative sign is also there. I hope you know root 4 when we write, or anything that you have which has the root value. Root 16 is actually plus 4 and minus. So right now, because we need two frequencies, so we are including the both of the root values, plus R and minus R. Okay.
Yes, ma'am.
Now when we add these two, see, this term and this term, they get added. Plus R and minus R are there. So see, R, when you add both of these, they'll be cancelled. So eventually you will get, see what I'll do, I'll take few things common from this side as well before writing on to this part. Omega 1L minus 1 by omega C plus omega 2L minus 1 by omega 2C. So from here, let's take the inductance common, L common. So this will be omega 1 plus omega 2. From here, minus 1 by C. If I take common, means from this term, from the capacitance term. So 1 by omega 1 plus 1 by omega 2 will be left. Minus 1 by C I have taken common, and this is equal to 0. So if it is 0, this term, if we shift on the opposite side, L is equal to omega 1 plus omega 2 is equal to 1 by C. 1 by omega 1 plus 1 by omega 2. Now let's take the LCM on this side. L omega 1 plus omega 2 is equal to 1 by C. This is omega 2 plus omega 1 divided by omega 1 into omega 2. So see, omega 1 plus omega 2, omega 1 plus omega 2 is equal to, is cancelled here. So from here, 1 by C into omega 1 into omega 2, this is equal to L. Till here, have you understood this whole calculation if we add them? Now we need this later on, that's why I've stopped here. This much is clear?
Yes, ma'am.
Okay. Now what we do, in the first place, we added these two equations. Now we'll subtract these two equations. Omega 2L minus 1 by omega 2C and omega 1L minus 1 by omega C. When we subtract both of them, so see, same thing will happen. But wherever you were getting the positive sign, now you will get the negative sign, right? Omega 2 plus omega 1 was there. Now you will get omega 2 minus omega 1. This is 2. Okay, similarly here also minus sign, rest of it will be the same. Here instead of 0, look, R is there, you have plus R, you have minus R. So R minus, now minus R. That time you were adding, so plus R minus R got cancelled. R minus minus R. So that is R plus R, which is equal to 2R. So see, now look, from here, this is omega 2 minus omega 1 into L. 1 by C. Okay, let me take here also common. See, omega 2 minus omega 1 is common from both of them. Here also omega 2 minus omega 1. Here also omega 2 minus omega 1. So omega 2 minus omega 1, if I take common, I'll be left with L plus 1 by C omega 1 omega 2 is equal to 2R. Here, these brackets are same. In the previous case, the brackets were still same. Both were getting added. But since we had a 0 on the opposite side, we could cancel the brackets. Right now, there is no 0. You cannot shift it on the opposite side. So you take this bracket also common. So what will you get? L from this side and 1 by C omega 1 omega 2 from this side. So 1 by omega C omega 2 we have already calculated. That is equal to the inductance L. So omega 2 minus omega 1 is L plus L is equal to 2R. Omega 2 minus omega 1L is there. This is equal to 2L is equal to 2R. So from here 2 will be cancelled. Now look, omega 2 minus omega 1 is equal to R by L. This is what we needed. Okay, because of the entire derivation. Now I'll tell you how. First, tell me the subtraction part simplification is clear? Whatever steps I have done? Others also? Only Ali?
Ma'am, which equations we used for subtraction?
These same equation. These two. We added them first. We got the value of 1 by C omega 1 omega 2 as L. And now we've subtracted them to get omega 2 minus omega 1. Okay.
Yes, ma'am.
Now see, quality factor is what? Resonant frequency by omega 2 minus omega 1. So quality factor is resonant frequency by omega 2 minus omega 1 is R by L. This is R by L. And what exactly is the resonant frequency? Resonant frequency is 1 by under root LC. Okay, resonant frequency is 1 by under root LC. So this will be L goes up. If this L goes up, L by R into resonant frequency will be under root 1 by LC. See, two L's are coming. Let's rationalize it. Multiplied by root L, divided by root L. So quality factor is L into root L divided by R into root C. Now root L into root L is L. LL gets cancelled. This is the formula for quality factor. 1 by R under root L by C. This is the quality factor. Now see, I'm just quickly repeating what have we discussed. The simplification part while writing you can understand. At resonance, Z is equal to root 2R. So we wrote the equation of Z. Now in Z also, XL is equal to omega L, XC is equal to omega C. So we put those values. Now R square plus omega L minus 1 by omega C whole square is equal to 2R square. So R square we have shifted on the opposite side and we got this. And we took the roots, both positive and negative. So these were the two equations that we obtained. Omega 2L minus 1 by omega 2C is equal to plus R. Omega 1L minus 1 by omega C is equal to minus R. So we add those equations. Resistance is 0. So here the negative term is shifted. LCM is taken, same brackets get cancelled. We keep the value of 1 by C omega 1 into omega 2 is equal to L for the subsequent equation. Then we subtract them. In this time, resistance instead of getting added, they get doubled because of minus into minus minus becomes plus. And wherever we add positive, that will be negative because we are subtracting it. So plus 1 by C we will take common because minus sign changes everything. So from here, since omega 2 minus omega 1 is common, we take it out and we are left with 1 by C omega 1 omega 2 here. This we've already calculated as L. So here this becomes 2L, 2 gets cancelled. So bandwidth value is there. Omega 2 minus omega 1 is what? That's the bandwidth, resistance by inductance. So quality factor is the resonant frequency by the bandwidth. So resonant frequency bandwidth is R by L. L goes up. So what we do, we get the equation as L by R under root LC. So since just to simplify it, we multiply and divide it by root L just to rationalize it. Root L into root L becomes L, which gets cancelled with this L. So finally the formula is 1 by R under root L by C. Tell me now, everybody tell me, have you understood this derivation? It's a little lengthy derivation.
Yes, ma'am.
Others, Anisa, Aisha, Marwa, Ali.
Yes, ma'am.
Okay, please start writing.
Ma'am, can you speak up?
Class, you can stop writing. Um, Time is up. 11:30 is here. So from here you can start writing. I think most of you must have completed the subtraction part. A little bit is there, but a major part of your chapter is done. This was the major thing. LCR circuit and resonance. These are very 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 important. Now power and AC transformers will be done in the next class. Okay, so two topics.